In this video, I want to talk about decoupling using Blueprint interfaces. In order to motivate that, I've created a level based on the third-person template, and into this level I've added an elevator and a yellow robot. If I run the level and press F8, I can select the elevator, and you can see that I've exposed a pair of custom events to start and stop the elevator. And similarly for my robot, I've exposed start running and stop running. Run in circles, stop running in circles. Okay. Now what I would like to do is have a pair of switches, one switch that controls the robot and one switch that controls the elevator, so that when I step on the switch, the robot starts running, step on it again, he stops running. Same thing here with the elevator. So the first thing to do is to link together my switches with the things they control. So let's go into this blueprint and we'll add a variable called target. The common superclass for both of those things in the scene is actor. This is just a regular blueprint actor. This is of course a character. So we're going to take the type here as actor, and we can make that instance editable, which then means back from the level I can select this switch and I can give it a target by picking this actor from the scene. Good. And this one, same thing, pick the elevator. Good. Okay, so if we go to the switch, we can see that I'm using begin overlap in order to run the logic of changing. Well, right now all it does is change the color. But this is where I would like to tell these guys to start and stop running. So because there's no convenient common superclass, right? This is an actor and this is a character. I can't just add a method to a superclass that then the two subclasses will override. What I might be tempted to do is when this happens, grab the target and then I can say cast to BP elevator, for example, and if that cast succeeds, call start elevator, and then try casting to my AI bot and then call the method start running. But you can see what that will do is tightly couple my switch to both of those other actors. And that's a bad practice in software development. It leads to fragile code, it's hard to maintain, and it can be hard to reason about as well. Instead, what I'd really like to be able to do is say both of these actors can be treated in the same way because they can be switched on and off. And that's exactly what a blueprint interface gives us. So let's go ahead and make one. Blueprint interface, BPI, let's call it switch controlled. Now this is an interface like in Java or C#. It's a set of function declarations without function definitions. So for my first one, I'll call it turn on, and I'll add another one called turn off. And that's all there is to the interface itself. But the things that are controlled by the switch have to declare that they implement that interface. So let's see how to do that. We can go to the elevator class, which I happen to have open right here. In the class settings, notice there's a section here of implemented interfaces. So we'll add our new interface, switch controlled. Make sure you compile that so that then we can use the autocomplete to find those two messages. So when we get the event turn on, we'll take one action, and when we get the event turn off, we'll take the other. Notice that these are annotated with the blueprint interface symbol to let us know that that's where that's coming from. In this case, this is pretty easy. I really just want to reuse what I had before with these two exposed custom events. By the way, if you've never seen that before, when you make a custom event, you can set it as call in editor, which is how I was able to access those after pressing F8 before. Okay, so now we have event turn on and event turn off in our elevator. Let's go to the bot class and do a similar thing. So we'll go to its blueprint and its event graph, and you can see here, here's start running and stop running, and very simple logic. So we'll do, first we better add the blueprint interface. So class settings, interfaces, switch controlled. Make sure to compile it. Then we can say there's a turn on event. Oops, that's actually calling it, sorry. Turn on, event turn on. Turn off, event turn off. And again, we'll just reuse that existing logic here. Good. Okay, so now we have a common interface through which we can communicate with both the robot and the elevator. So let's go back to the switch. So now we can say, okay, let me move this out of the way for a moment. So when the switch is turned on, then we want to take the target and we want to call turn on. Now notice it recognizes this as a message that's sent through an interface. Turn on or turn off. Oops. Here we are. And after that, we can update the color of the switch just like before. That's why I had a flip-flop there to begin with, because I knew this is where I was heading. Okay, let's try it out. Run the level, step on this switch. There he goes. There goes the elevator. Turn off the elevator. Turn off the character. So blueprint interfaces are a really useful way to be able to take a whole range of different classes and be able to treat them in a similar way by sending similar messages to them that they can then handle in their own actor-specific way. I hope you enjoyed the video. Happy programming!